everyone, welcome to JavaTechie. In this tutorial, we'll discuss about reactive programming. Basically, we'll cover what is reactive programming, why we need this reactive programming, and when to use this reactive programming. Okay, alright. Let's deep dive into the core concept of reactive programming. Basically, these are the core features. This is a new programming paradigm and it is going to a new complete shift the way we are designing our application previously. Also, as per the documentation, it is asynchronous and non-blocking. If you are familiar with Java Stream API, you may need to write lot of functional style of code. It supports data flow as a event-driven stream. Also, it supports back pressure on data streams. Don't worry, each core features we'll understand in details with example. So let's begin with what is asynchronous and non-blocking. Let's assume I am the owner of one restaurant and I can accept order from any third party. It can be Swiggy, it can be Zomato, or I can directly accept the order from customer itself. Let's assume I accept the order from Swiggy, that is order 1. Then I pass that order to my cook for prepare the food. Now I just wait for food to be cooked. Okay. After few minutes, my cook update me the order is ready. It took around 30 minutes. Once I receive the order, I will serve it to the customer. Okay. Then again, once I serve, I will accept another order. Let's say order 2. Then I told cook for prepare the food. Then I wait for the food to be cooked. Once I got the food, then I will give it back to the customer. Okay. After all of that, then again I will took the next person's order. So if you observe, the flow of execution is one after another, which is nothing synchronous flow. I will accept the order, then I will follow all the 4 steps, then I will accept another order. Okay, that is what called synchronous and blocking flow. Because my restaurant is completely blocked for the cook. Until I will not get response back from the cook, I am not accepting the next order, which is completely synchronous and blocking. And also if I'll continue my restaurant in same pattern, then I could not deliver more than 50 orders per day. And you would have a line out the door and customers waiting for long, which is not in a good way, right? Let's optimize this in a reactive programming manner, which is asynchronous and non-blocking. I accept the order from Swiggy, which is order 1. Then I pass it to my cook for preparing the food. Now, instead of waiting for it to be cooked, I will take the next person's order and I will tell to my cook, you just let me know once you are ready with the first order. Then again I will accept the next order. I will again not wait for my cook to be prepare the food. Then again I will accept another order. I will accept n number of order. My cook can continue cooking the food based on the order priority. Okay. Let's assume cook is ready with any of the order. It can be order 2, order 1 or order 3. Once I listen from the cook that order is ready, I will serve it to the customer. So in this approach, what we are doing, we are taking the customer's order, then we are tell the cook to prepare the food. Then instead of waiting for it to be cooked completely, we are accepting the next person's order and we are waiting for our cook to tell you the first customer's food is done. Once we receive the order confirmation from our cook, we are returning back it to the customer or we are serving to the customer, right? Which is completely asynchronous and non-blocking. Now my restaurant is not blocking with this cook. I am ready to accept n number of order per day where I will just inform to my cook, you just let me know once you are done with the order rather than waiting for it, isn't it? Which is completely asynchronous and non-blocking. And if you compare in this asynchronous and non-blocking, you can achieve lot of advantages. For example, we can handle more requests with the same amount of employee by using a publisher and subscriber model. So here the restaurant owner is a subscriber and cook is a publisher. I just subscribe to this cook and I just inform him, you just let me know with the event when you are ready with your cook or food. Okay. So this cook will be publisher. He will publish the event. Okay, I'm done with the food. You can deliver it. So as a subscriber, I can hear that. Okay. That is what. And the next we can say you get more work done during the time you would normally be waiting for the cook to cook the other order. That is what we understood in our previous slide. You no need to wait for the cook to be prepared the food. Just accept the order and process it. This is what the advantages in case of asynchronous and non-blocking. Hope this is clear for you. Now let's link this concept to our application level understanding. Usually, traditional REST API worked on thread per request model. If you can see this diagram, let's assume client send request to my application. As you already know, each request will be served by a separate thread. So here we can consider request 1 assigned to thread 1. Now this thread 1 go to DB and try to fetch the database. Now here until thread 1 get response back from DB, he is completely blocked. So he is waiting for the response. Okay. Similarly, let's assume we received another request to application and it is serving by thread 2. And again it go to DB and waits for its completion. Until then it is blocked for a long, isn't it? Similarly, we can process n number of requests, but in real time there is a thread pool limitation. Let's consider my application thread pool limit is 20. It means my application can handle only 20 concurrent requests at a time. If my application receives 21 request count, then that request need to be wait until any of existing thread is free, because all my thread is blocked by this database driver for getting the response, which completely give us poor performance as it seems blocking asynchronous flow, because all the thread is already occupied with this DB driver to get the response. That's the reason 21 count request is not immediately handled by any of the thread. Okay. So that's where reactive programming came into picture, and it eliminate use of thread per request concept. Now let's understand how it works on reactive programming. In reactive programming, let's say request came to my application and it assigned to thread 1. Now thread 1 will go to database for fetching the data. But the advantage is here, he will not wait to get response back. Instead, he will send an event to database and he will inform to database, hey, I am not going to wait to you anymore. You just do your job. Whenever you will ready with response, assign that response to available thread and just publish me a complete event. Okay. Now in that case, my thread is completely free. He can happily accept n number of requests because not a single thread is blocking in this event loop approach, isn't it? With this approach, you can handle tons of concurrent requests with very less thread. That is what asynchronous and non-blocking. Request assigned to the particular thread, and thread is not going to wait for database driver to get the response. He will continue his process. He will accept n number of requests simultaneously. That is what the all about asynchronous and non-blocking. Let's move into the next core feature, that is functional style code. In traditional REST API code, let's say I just want to delete a user from database, I can write something like this. Delete user, you can pass the argument, then you just call your database dot delete by id and pass the argument, it will delete the object from database, right? But in case of reactive programming, the syntax is bit different. So you can observe this syntax, right? There is a data type called mono who can handle single object. Also there is another data type called flux. He can handle 0 to n number of object. Then you can write delete user, then pass the argument, then get the existing user, then use the dot flat map, and there is a syntax called mono.just. So the syntax in reactive programming, it is similar Java 8 Stream API. If you are not familiar with Java 8 Stream API functional interface uses, you can check out my Java 8 playlist. Okay, so that it will easy for you to understand the reactive programming syntax, which is nothing functional style code. You'll understand more about this code once we start our coding session in our upcoming courses. Now let's move into the next core feature of reactive programming, which is data flow as event driven stream. So if you can see this diagram, typically in traditional REST approach, client send request to application, then request goes to database and process the data, then finally it return response back to the client. But what if there is a few record inserted or modified in middle? Now client don't have those update information. To get that update information, again he may need to do a separate REST API call. But how it works in reactive programming? If there is any changes done in database, then immediately it will fire or it will publish an event, hey, there is a new data found. Now whoever subscribe, they can stream the data. In this case, if you observe, my client is a subscriber and my database driver is a publisher. If any changes happen to my DB, he will publish a event. As my client is consumed to my application, he can easily stream the data. And also in this scenario, your connection will be always open state. That's the reason we can perform this publisher subscriber operation, right? We can consider any streaming platform that work in reactive programming manner. The best example you can consider cricket live score. We are seeing the cricket live score, right? Any update happen in the application, we can see the current score with the updated details. So this is how the data will be transferred as a event, okay, on the publisher and subscriber model. That is what data flow as event driven stream, which was supported by reactive programming. Fine. Let's move into the next core feature of reactive programming, that is back pressure on data streams. Let's assume I just want to get all the items from inventory. Now my application send request to database and database return response as a large volume of data. Okay. In that case, my application may not be able to handle huge amount of data, or my application may crash with out of memory because no back pressure feature was available for traditional REST API. But in case of reactive programming, there is a concept called back pressure. If your database gives huge data and your application not able to handle it, you can simply tell to your database, hey, please slow down the response. Let me process with whatever data I have with me. Then you can push other data. Okay. So this back pressure support only applicable for reactive programming, where you can add a limitation on database driver how much data you are expecting. Okay, you don't want to load all the data, you can inform to your database driver, he can slow down the data based on your configuration. That is what the advantages of using this back pressure. So far we cover all the theoretical term of these core features of reactive programming. Don't think too much about its internal details of how it works. Don't worry, I will covering all these concepts in upcoming videos. We will be exploring all these key components of reactive programming in code in the future part of course. Okay. So far we just understand the advantages of reactive programming. We can achieve proper CPU utilization and there is no application downtime, and the flow of execution can be concurrent because it supports asynchronous and non-blocking, right? Also, it's streaming the data as an event using publisher and subscriber model. All these things we are going to hands-on with the code in our future course. In previous tutorial, we understand what is reactive programming and when to use it, right? In this tutorial, let's deep dive into its specification or rules. Basically, reactive stream specification is nothing, it's just a rule to design a reactive programming. The way we have rule to design a object oriented programming language, similar way we need to follow certain rule in reactive programming. Okay. Specification is very simple. It has only four interface: publisher, subscriber, subscription and processor. Okay. So these are the four interface which will be pillar of reactive stream specification or reactive programming. And each interface has couple of abstract method. Don't think much about these method signature or don't try to by heart the things. We'll be exploring all the methods with its implementation in code in our next tutorial. For now, let's have a look in each method of these interfaces. Okay. So the first interface is publisher, or you can pronounce it as a producer. Publisher is a data source who will always publish an event. So if you observe in this publisher interface, we have only one method which is subscribe. Now subscriber need to call this subscribe method to register into publisher. So we'll understand this flow in our upcoming slide. Now the next interface is subscriber, or you can call it as a consumer. Subscriber will subscribe or consume the event from publisher. If you observe the method signature, it has four abstract method: on subscribe, on next, on error, on complete. If there is no error in your event processing, then you will find this on complete event. If there is any error, you will find this on error event. And in each data transfer from publisher to subscribe, you will find on next event. Let's assume your publisher is publishing 10 event, then you will find 10 on next call. Okay. Now the next interface is subscription. Subscription represent the unique relationship between a subscriber and publisher. So if you observe the method signature, it contains two method: request and cancel. So subscriber will call this request method to get the details from the publisher, to get the data from the publisher, and there is also a cancel method. Okay. So you'll understand this all the method in the workflow. And next interface is processor. A processor represents a processing stage which is both a subscriber and a publisher, and it must obey the contract of both. Okay. So if you observe the method signature, it extends from both subscriber and publisher. So it should obey the contract of both publisher and subscriber. Okay. Now let's put all interfaces together and try to find out the workflow in reactive programming. If you can observe, I have publisher and subscriber. Now the first step, subscriber will invoke subscribe method of publisher and pass the instance of subscriber instance as a input. Now the next step, publisher will going to send a subscription event to the subscriber confirming that your subscription is successful. Now after that, subscriber will call request method from subscription interface to get the data from publisher. So if you observe, the method signature is request n. N means subscriber can request n number of data from publisher. Now next, publisher will send data stream to subscriber by invoking on next method. But let's assume publisher is returning 10 record. Then in that case, publisher will fire 10 times on next event. If publisher send n number of data, then there will be n time on next event process, or it will execute on next event 10 times. Once all the record received by subscriber, then publisher will invoke one onComplete method of subscriber to confirming, hey subscriber, I am done with my job, your execution is successful. If there is any error, then publisher will fire on error event. Okay. All right. Also, there is a option for subscriber to ask limited number of data from publisher. For example, let's say publisher have 10 item and you want to fetch only 2 item. Then subscriber can control that. If you can see this method signature request n. So if I will pass your request to, then I can fetch only 2 record from publisher. That is what all about data backpressure in reactive stream programming. Okay. So far we understand how this publisher and subscriber talk to each other through these are the interfaces. So the first step, subscriber need to register to this publisher by call this subscribe method. Now publisher need to send one subscription event to the subscriber. Then third step, subscriber need to get the data from publisher by requesting this request n method from subscription interface. Now publisher will publish the data to subscriber by calling this on next event method. Then as number of record or number of event, that will be fired n times on next event. Then on completion you will find on complete event. If there is error, you will find on error event. Okay. Also you understand how this back pressure support through this reactive programming. Fine. We understand what is reactive programming and what's its specification, right? Now let's understand how to build reactive programming. I mean, what all library or frameworks are available in market to design a reactive programming. So if you can see this, there is 3 library through which we can design a reactive programming: Project Reactor, RX Java, and JDK9 itself provided one reactive stream implementation. Okay. In our entire series of course, we'll use Project Reactor because it is recommended library to work with Spring Boot framework. Fine. Let's do some quick review about this Project Reactor and its modules. So if you'll go to the browser and if you'll type Project Reactor, if you'll go to the first link, then go inside documentation. Then you can find there are couple of modules: reactor core, reactor test, extra, reactor neti, reactor adapter, reactor Kafka, and there is lot of modules given to this reactive programming. Okay, and it all supported by Spring Boot framework. So in this particular course, we are going to cover reactor core, reactor test, and reactor neti. Based on the viewers response, I will try to cover other modules as well. Okay. Alright, so we understand what are the modules available in Project Reactor. Now, what are the data types we need to work with this reactive programming? So if you'll go to this search bar, you can see there is a two component, right? Flux and Mono. So these are the two Project Reactor data type through which we can design our reactive programming, and with this Flux and Mono, we need to play with JavaTechie Stream API. Okay. Basically, these are the data types which used in reactive application. We'll understand more about these two data types once we start writing code. In my next tutorial, I will show you how to use Flux and Mono. With the help of this Flux and Mono, we'll try to understand the flow which we discussed just now. Even though these are the theories, you need to understand the concept behind the reactive stream and how it built in roughly. then it will very easy to program the application using this reactive stream. Otherwise, if you don't understand the base concept or basics or theory, then it's very difficult for you to writing the code in reactive programming approach, and always you will be doing the googling and copy pasting the code. Sometimes it may work or sometimes it may not. So don't lose this context. Try to brush up both the two theory session which I covered so far. Now from next tutorial onwards, we'll try writing the code and we'll only do the implementation. In this tutorial, we'll be exploring about Mono and Flux with its internal workflow. Okay. Also, we'll verify the steps which we discuss in reactive stream workflow using this Mono and Flux. Basically, we'll be creating one small project to demonstrate this Flux and Mono and its internal flow. So let's quickly create one Spring Boot reactive project. Go to your favorite ID. I will be using IntelliJ ID. Then click on File, click New, click on Project, click Spring Assistant. You should add this plugin in your ID. Now click on Next. Then change the group ID here. So I will add com.javatechie. Then change the artifact ID. I will name it Spring Boot WebFlux Demo. Then change your Java version. I will use 8. Let me copy the artifact ID so that I will specify same as my project name. Then change the package here com.javatechie.webflux. Now click on Next. Now you need to add the reactive dependency. So let me type here Spring Web. If you observe, there is two Spring Web dependency. One is Spring Web and another is Spring Reactive Web. Okay. Since we are doing the reactive programming, I need to choose this Spring Reactive. Now click on Next. Finish. Then go inside your project. Now if you will open your pom.xml, you could see the latest version of Spring Boot we are using 2.4.4, and we added only the dependency Spring Boot starter WebFlux. Okay, and this is the default dependency for test, and there is a dependency called reactor test, and this is what the Maven plugin, right? So only one dependency which we added, that is the Spring Boot starter WebFlux. Now I'm not going to write any API here. I'll just write one test case to show you the workflow of Mono and Flux. Now go inside your src test. Then I'll create one class. I'll name it Mono Flux Test. So we'll be begin with Mono. So what I'll do, I'll write one method public void then test Mono. Okay. So there is multiple way you can create object of Mono. So what I'll do, I'll just type Mono dot just. This is how you can create object of this Mono. Now, as we already understood, Mono can only handle one element. So I will add here any kind of data type. I will add ABC. If I want, I can type 1. It's up to you which kind of data type we want to use. Okay. So for this example, I will use something called string JavaTechie. Now the return type will be mono of string. Okay. I will name it mono string. Fine. This is how you can create object of Mono who can handle only one object. Fine. Now if you will go inside your Mono class, so let me go to this implementation. If you observe the package structure, reactor core publisher, it means this Mono and Flux will act as a publisher, right? So to access any publisher, first subscriber need to call subscribe method of publisher. So here my publisher is Mono string. Now subscriber need to call monostring is my publisher dot subscribe, right? So if you remember, this is what the workflow we understand, right? First subscriber need to call subscribe method of publisher. That's what we are doing here. This is my publisher and we are invoking the subscribe method. Then if you observe, the subscribe method is one overloaded method. There is a multiple subscribe method. Okay, you can observe here. So what I want to do here, I just want to print the published event. So I will directly use method reference system.out println. Fine. Now I just annotate this with @test. Let's run this piece of code. Run this Mono Flux test. Yeah. So we are seeing the event here, right? Once we call publisher.subscribe method, then immediately publisher start emitting the event. That's how we can see the result. Now what I need to verify, I just want to verify whether this Mono and Flux is really following the reactive stream workflow or not. So for that reason, I will add one method called log. Now each of execution will be printed in console. Now let's rerun this piece of code. Yeah. So if you observe the output, there is a unsubscribe method call, then there is a request method call from the subscription interface, then on next method call from the subscriber interface, then on complete event, right? So let's go to the diagram once again. The first step, we just need to subscribe to the publisher by calling this subscribe method. Then publisher need to send the subscription event to subscriber. Then if you observe the third request, third need to be the request method from the subscription, right? So subscriber is invoking this request n method to inform to the publisher, give me n number of data. That's how the method argument is n. And then the fourth step will be on next, right? And if there is n number of event, we'll get n number of on next method call. As we are trying with the mono, I cannot show you this n number of event. Once we will try with the flux, I can show you this output. Then at end you can observe we are receiving the uncomplete event. Now if you'll go back to the console, the first method is unsubscribe. Then there is a request method from the subscription interface with n number of argument. Then once publisher call this on next method, we are receiving the event. Then as everything is okay, there is no error, we are getting incomplete event. Now if you go to the diagram, if there is any failure, we should receive on error event, right? Now let's verify this on error event. So what I'll do, I'll forcefully try to throw some exception from this mono. So let me minimize this. Then what we'll do, we'll just add here. Then I just want to mono dot error, new something called runtime exception. Just pass the message exception occurred, something like that. Okay, just change this to type generic. Fine, because this will return the object and we are mapping here the string. So now forcefully we are throwing some error while processing the mono. Now let's verify whether it return on error event or not. Let me run this piece of code. We are getting unsubscribe, then request, then on error. There is no on complete event. If you observe, there is no request on next event as well. Okay. Now we are not handling this exception. So what we can do, as the subscribe is overloaded method, I will try to print the exception. Sysout. I'll just print this message. Now let's rerun this. It called unsubscribe, request, on error. There is no on next call and on complete call. Okay. So the error handling scenario is something different in reactive programming. So we'll cover a separate session for error handling. This is just I was trying to show you the flow of on complete and on error. Okay. Now we'll just verify if publisher will publishing n number of event, whether we are getting n number of on next call or not. So what we can do, I will go with the flux. So I'll write another test case, public void test flux. Then I just need to create the flux object, flux dot create. I will pass here n number of element, or I can just name it to flux.just. Okay, so here I will give something called spring boot. Then I will add hibernate, some random value. Okay, so I'll add another string, let's say microservice. Fine. So define the local variable flux string. Fine. Now this flux string will be act as my publisher. So to consume this, what I need to do, I just need to call the subscribe method of my publisher. So just call it. Once you call this subscribe method on flux, it will immediately start emitting the event. It will emit the 4 event. Okay. So what I will do, I will just print it. So I'll copy this directly. Fine. Now let me run this piece of code. So we need to annotate @test. Let's run this. We can see the result, right? Spring Boot, Hibernate, and microservices. Each of the message or each of the data published as a separate on next call. So to verify that, what we can do, we'll just add one log method. Now let's run this code, not enter test case, because on the first one we are getting the exception, right? I'll run this. Yeah. So if you observe, the first call is unsubscribe, then request n number of object from the subscription interface. Then if you observe on the first on next call, we are receiving one event. On the second on next call, we are receiving another event. Like we have 4, so we are 4 on next event, right? And at end, we are getting incomplete because there is no error. Now in middle, if I want to add something, let's say I'll just add dot concat with value. I'll add something called AWS. Now my publisher will fire 5 events. So there should be 5 on next call. Now let me run this. Yeah. So if you observe, there is 5 on next call. Now let's verify the error scenario. So what I want to do, I just want to forcefully send some error. Okay. So I can write concat with flux.error. I'll return the same exception object. So I'll add the message exception occurred in flux. Fine. Now if I will run this, we are not handling the exception. So let me add this. We are not handling, we are just printing the message. So this will be second argument of subscriber. Now let's run this. So if you observe here, there is unsubscribe call, request call, then 5 on next event, then at finally we are receiving on error event, right? As there is error, we are getting on error. If there is everything succeed, we should receive on complete event. Now what we just need to verify, after this error, if I will add some value to this existing flux, whether it will do the on next call or not. So what I will do, I will add something called here cloud, so many random string. Now let me run this. So if you observe this output, we don't have this cloud on next event, right? Still we can see only 5 on next, and at end we are getting on error. So this is how it follow the reactive stream workflow. Once again, if you see this diagram, the first we need to subscribe, then publisher need to send the subscription event, then there will be a request n call. So let me remove this. Yeah. So there will be request n method call from the subscriber from the subscription interface. Then there will be on next event will be published from the publisher to the subscriber, and the number of record you have, you will find that many in on next event. Then at end you will find on complete or on error event. This is what we understand with our code, right? So I believe this concept is clear for you. In our upcoming tutorial, we'll understand how this asynchronous and non-blocking works in reactive programming with live example. Okay. So once again, don't ignore this theory session. Just try to brush up once again so that it will help you to understand the next tutorial. So far, we understand what is reactive programming and its specification with example, right? But if you remember, in our first reactive introduction video, we discussed a term called asynchronous and non-blocking. If you can remember this slide, as part of core feature of reactive programming, we already discussed this term called asynchronous and non-blocking. What it means. Let's understand this term in action. If you understand this example, which you are going to develop in this tutorial, you will get your answer that why we need reactive programming. Okay, so let's get started. Let's go to the main folder and let's create a couple of packages. Basically, we are going to expose one REST endpoint who will return us thousands of record. Then we'll try to understand how it works in reactive programming approach and our normal traditional REST approach. Okay. Then I can differentiate asynchronous and non-blocking, synchronous and blocking approach. So let's go to the main folder. Let me create a couple of packages. Let's say I will create a package called DTO. Then we'll create a package called service. We'll create a package called controller. In this example, I am not using any database. I will return the hard code list of object. So I will just create a package called DAO. Then anything else? I guess no. We created all the package. Now let me create one DTO, which is customer class. So I will add private int id, private string name. So in this example, I just added one dependency, Lombok dependency, which I just added to save the time. I'll share this code link in video description. Now go to the customer class. We no need to write manually getter and setter method. I can use at the rate data annotation of Lombok. Then I want all argument constructor. I want no argument constructor. Now let's create one DAO class where we'll return list of customer object. Now go to this DAO package. I'll create a class called customer DAO. Then I'll simply annotate at the rate component. Then I'll write one method who will return me list of object. So I'll write public list of customer get customer, something like that. So for example, let's say we just want to return 50 customer object. So what I'll do, I'll just use int stream dot range closed 1 to 50. Okay, then I just want to map this 50 record to this customer object. Okay, so I'll do map to object new customer. I'll pass id as the index value I, then name as a customer I. Okay, then just return as a to list. Now when I will call this get customer method, I'll get 50 customer object. So let me format this. Fine. So just return it. Also I just want to print the process count. So what I'll do, I'll just use dot peak, then the lambda, Here I'll write sys out processing count, just add the I. Fine. So this method will return me the 50 customer object. Now what I'll do, I'll just do the get customers method call from my service class. So now let me write one service class. Let's say customer service. I'll annotate here at the rate service. Then here I just need to inject my DAO, private customer DAO. Just add annotation called auto add. Now I'll just call this method public, who will return me the list of customer, load all customers. I can directly return it from my DAO class, right? But I just want to print the execution time as well. So what I'll do, I'll just add system dot current time millisecond. Let's say long start value. Then I'll just copy, just do the method called DAO dot get customers. Okay, it will return us the list of customer object. So just add it. Then I will just add end time. Okay, then just return this customer. This is what first I am trying to explain you in our traditional way. Then we'll find the disadvantages and I will show you how it works in reactive programming. So what I'll do, I'll just print the time difference. Total execution time end minus start. Fine. Now let's write one controller class. So just go to controller package, create a new class. Let's say customer controller. Just annotate this at the rate rest controller. Then I just want to map the URL slash customers. Okay. Then just write one endpoint who will return us the list of customer object. Get all, something like that, or get all customers. Then I will just inject the service here, private customer service, just inject using auto add. Now call this return service dot load all customers. Okay, then just annotate at the rate get mapping. That's it. Now let's try to invoke this REST endpoint with slash customers. Then we'll see how it behaves. This is the traditional way usually you do, right? So let's go to the resource and let me change the server port. Server dot port equal to 9191. Fine. Now let's start our application. Go to the main class. Let's run this Spring Boot application. Yeah. So if you can see this, here the application started in this 4.8 second. Okay, and it's up on port 9191. Now let's go to the browser and type localhost 9191 slash customers. Okay, I guess we added one more URL. Fine. So you're getting all 50 record, right? ID is the index number and name is append with the index. So we are just getting 50 record, which is not a huge data. So I could not show any difference in our traditional approach and reactive programming. So what I will do, I will try to sleep my execution thread for 1 second. It will return one record, then it will sleep for 1 second, then again it will return one another record. If we have million of record or thousand of record, we can easily catch what is synchronous and blocking in this traditional approach. So to make it visible, I'm just going to sleep my thread for 1 second for each execution. So what I just need to do, just go to your DAO class. Now this DAO will act as a publisher and this browser will act as a subscriber. Okay. So let's go to the DAO. Then what I'll do, I'll just use dot pick. Then I'll just use thread dot sleep. Thread dot sleep for 1 second. So I'll just convert it to method reference, or else you can add it here itself. Better, let's convert it to the method reference. So I'll write a method private static void sleep execution. Okay. So I'll add the parameter here int I. Then I'll write thread dot sleep 1000 second, sorry, 1 millisecond. This is the 1000 millisecond. It means it is 1 second. Okay. So I'll just use try catch. Now in my this method, I can directly use the customer DAO dot sleep execution. Okay. So just add the proper naming convention. Fine. Now let's stop the application and let's rerun it. Okay, there is some error. DAO dot get customers. Okay, we just need to remove this. Now let's run it. So you can see our application is up, and also here it is not using embedded Tomcat. It is using Netty server. That's how it will work on the event loop in case of reactive programming. Now let's go to the browser and let me open a new tab. Just add it here. Now go to your console. If you observe, it is printing the processing count and we cannot see the any response. Still it is buffering to get the response. This is what called synchronous unblocking. Until it process 50 record, my consumer or my subscriber will not get the response in our traditional REST API approach. Still it is buffering. So once it reaches the count to 50, we'll get the response because manually I sleep my thread for 1 second for each execution. So see the count is 36. We are not getting any response. Still it is buffering. Now it is 43, 44, 6. Still we don't have any response. Yeah. Now it reached to 50 and it took total execution time this. Now you can see the response here, right? So if you have million of record, you don't need to manually sleep your execution thread. Okay. So you'll find the actual clarity on what is synchronous unblocking. Now how we can avoid this using reactive programming? Now let's understand that part of code. So go to your DAO. So far you understand what is synchronous unblocking, I believe, because there is a processing count. Until it process all the record, we are not getting the response back. Now let's try to understand how we can avoid that using reactive programming. So let me stop this application. Now go to the controller. Let me copy this, then add it as a separate endpoint. Just change the method name, get all customers stream, something like that. So let's not use the additional slash, remove it. Here I will add the URL as stream. Okay, fine. Now if you remember, this reactor programming will work as a flux and mono as a data type, right? So list will be underlying data structure who will store the customer object. But in case of reactive programming, if you will use list, then there is no mean of reactive programming. We just need to change it to the flux because that will be my publisher. Now just go to the service and let's write another method. Let me copy this, paste it here, load all customers, stream. Now let me add this method name in controller. So again it will accept flux, not here. And then if we'll go to DAO, here also I need to change the flux. Then same we need to change in our DAO class. So in DAO also I can copy this piece of code and then I'll add it. But if I'll do in such a way, then that is not a reactive programming. So what I need to do, instead of using this int stream.range, I'll directly use flux.range. Okay. So day by day we'll understand the syntax. It is bit complex as compared to our traditional way of designing code, but it's much more handy because the entire execution will be in single pipe. So let me write that flux dot range of 1 to 50. Okay, then we just need to map this count to customer object, right? So I'll copy this, just add it here. So we just need to use the map method, not map to object. Fine. Now also I just want to print this processing count, right? So just copy this, just add it here. The method name should be do on next. If you remember, we understand do on next method from subscriber, right? I guess in previous example we understand when it will execute. If you have 50 event, then it will execute 50 times. That's the reason I can able to see my print statement. Then what else? I just want to sleep my thread for 1 second, right? So what I'll do, I'll just use delay elements duration of second 1 second. That's it. So yeah, just change the method name to stream, and same method I just need to call from my service. This will be flux of string, not list of flux. Flux of string customer, what is the problem? Okay, my bad, this should be customer. Fine. Now we created, if you'll go to the controller, let's cross verify again. We created separate endpoint for stream API, means stream programming. So if you observe, we are using flux, and again if you go to DAO, rather than using this Java 8 syntax, we are using flux.range, and we are dealing the element for 1 second, and then we are doing the do on next call to print it. So I'll use processing count in stream flow. Then we are just creating the object and we are returning back to the subscriber, right? Now let's run our application to see the difference, how it works in reactive programming and how it works in our traditional way. So what I'll do, okay, let's remove this. Now let's run our application. Yeah, so if you observe, our application is up on port 9191. So I just want to do one small customization. Instead of waiting for 50 record, just reduce it to 10 so that we can save our time. This is just for testing purpose. Okay, now let me save this. Let's rerun our application. Yeah, it is up. Just go to the browser and let me copy this endpoint. This is what the traditional way we are trying, right? So it will wait for 10 seconds. If you observe here, the processing count 2 3 4 5, still we are not getting the response. Once it reaches to 10, now we have the response here, right? Then just verify the same in reactive way. This is what we added one new endpoint, right? So let me copy this URL, then try in another tab, stream. If you observe, it is doing the one after another, right? Then I didn't find any difference between the traditional way and reactive stream. So what is the advantages of using this reactive stream here? Only 4 millisecond and this is the millisecond. This is not the exact difference. So even we enable the reactive programming, still we are getting the result in a single flow. So what you just need to do, go to your controller class. In this reactive programming, we need to send the data as a event stream rather than sending as a entire object. So that's the reason we are not achieving the reactive programming way. So what we just need to do, we just need to enable the produces media type. So media type need to be import from org.springframework.http. Okay. Then we just need to use text event stream value because I just want to send my data to subscriber as a event stream. So just add it. Fine. Let's restart our application. Stop this and restart it. Yeah. So our application is up. Now let me clear this. Go to the browser and let's try to hit for the traditional way. I'll just add enter. This is the previous request data. So it is still processing to get all the record. Then it will display the actual result. Okay. Finally, we received it. Then if you observe in browser, you can see the response. Now let me try the same. So let me clear this. I'll try it for stream. Once I enter stream, if you see there is a count and immediately we are getting the response one after another. This is what the asynchronous and non-blocking. In reactive programming, my request is not wait to complete the 10 customer object. Once it completed one customer object, then there is a do on next call from the subscriber and my subscriber can receive it. So in this case, my browser is my subscriber and my database is my publisher. But here we just hard coded the value. In upcoming series, I'll show you using the MongoDB reactive database. Okay, so let's retry it again. It will be more visible for you. So let me minimize this. Yeah. So I'll just trigger it again. If you see the count, you are getting the response here immediately. It's not blocking anywhere. Fine. It completed 10 and we are getting the response back. This is what the advantages of using this reactive programming over our traditional approach. My publisher will keep pushing the event as a stream to my subscriber and on each stream will be transferred through the do on next call. Now apart from that, if you observe, I just want to highlight one more thing in reactive programming. Let's say let me try the actual endpoint, not stream one. Let's try the traditional one. Now we just enter it in middle as a subscriber. I don't want to get the response. If I'll stop it, still my backend is processing data. Where already subscribed, cancel the request. Okay, let me retry it again. In stream, if I will cancel the request at fifth, then immediately, if you observe, after fifth, 5, there is no another request flow. That is what one advantages of using this reactive stream. Apart from asynchronous and non-blocking, when your subscriber cancel the request, immediately it stops the execution. The request will not go to my backend code. But in case of traditional approach, even though we subscriber cancel the request, still it execute in backend. So let me show you once again. This is the traditional way. In middle, I cancelled. But if you go and check in browser, still it is going on. Right? This is one more advantages of using this reactive programming. So far we understand what is reactive programming and hope this session will answer you why we need reactive programming and when to use reactive programming. Apart from that, we also understand the flow of reactive stream and that is what we could see here. In each event will be transferred through the do on next call to my subscriber and publisher will keep on pushing the data. So far we understand basic of reactive programming using WebFlux, right? Now in this tutorial, let's understand what is functional endpoints in reactive programming and how we can write it. But before we jump into the code, first let's understand how this functional endpoint different from REST API. So if you can see this diagram, usually in REST API, client need to send request to the controller, and based on the incoming URL, controller logic will execute and it will call the service. But in case of functional endpoint, client will send request to the router. Now router will take care to redirect that request to corresponding handler. So the way we have something called request mapping in controller, same role will take care in the router section, or we need to add such kind of implementation in this router, so that based on the incoming request, it will redirect to the corresponding handler. So this is an alternative to the annotation based programming model, but otherwise both runs on the same WebFlux reactive Spring Web foundation. Also there is no restriction. If you want, you can add both in your code. You can write REST API as well as the functional endpoint as part of reactive programming. So let's understand how we can write this functional endpoint. Let's get started. Let's use the same code which we understand in our previous tutorial. Now what I'll do, I'll just create a package called router, new package called router. Then I'll create another package called handler. Okay. Then just create a class in this router package. So I'll name a class something like router config. Then we just need to annotate this with @configuration. Fine. Then here we just need to write one router function, so that based on the incoming URL, we can redirect that request to corresponding handler. So there is a method we can use that router function. This is what the return type. Okay. So return type of server response. If you observe, this class came from web reactive function. Okay. Now give the method name something like this. We just need to annotate this with @bin. Then here we can write return router function, router functions dot route. Then we can route n number of endpoint. So based on your HTTP method, let's say I just want to return list of customer object. So I just want to expose one get API. Okay. So if you can see, there is a overloaded method. So use any of one, then just pass the URL. Let's say if I will pass URL router slash customers, then it will return me the list of customers. Okay. So for that, I just need to write a handler here. For this particular URL, I just need to map a handler. So what I'll do, I'll just create a handler class, Java class. Let's name it customer handler, something like that. So I'll annotate this as a @service. Then I'll write one method, but already we are exposing list of customer object from DAO class, right? So I can directly inject the DAO here, private customer DAO. Then I will use auto add. Now if you'll go to the DAO class, you can see the method get customers, right? It will return the 10 customer object, and it will print it, and it will also stop for 1 second, right? So I don't want that. I just want to return without any sleep or without blocking my thread. So what I'll do, I'll just copy this simply. Not this one, I can directly copy this. I'll create another method get customers. Also I'll show you how we can write the functional endpoint for this stream as well. So now I just want to return flux of customers, okay, without any delay. Just remove it, get customer, something like this. Where there is error, yeah, I'll just return the 50. So let's name it get customer list. Okay. That makes sense. Fine. Now I will just call this method. Go to your customer handler. Then we just need to write here public. Then I will just want to return the mono of server response. Okay. So this is what the pattern you need to follow in case of functional endpoint. So server response. Then give the method name something like load customers. Then we just need to pass the argument, that is server request. So there is a two predefined class, server request to get all the request metadata and server response to map all the response metadata, right? So the name you can write like server request. Then what we need to do, we just need to call the DAO dot get customer list, then map it to local variable customer list. Now we just need to return server response dot okay. Then you just need to pass the body. Just pass this. If you observe, there is a two overloaded method body. So first method is the argument, which is your return, and the corresponding class type. So just add it. So the object is customer list of type customer.class, right? Fine. Now just inject this handler class in your router. So what I will do, I will just add here private customer handler something like that. I'll annotate using auto add. Then simply I can write handler double colon load customers. Then just build it. Here if you observe, I have the route and I have the endpoint, or I have the HTTP method. Now here if I want, I can write n number of method or n number of HTTP method. I can do the post, I can do the delete. So we'll do it. Let's test this API. Then we'll write for the stream one. Now let's run this piece of code. So I will start the application. Yeah. So you can observe your application is up on port 9191. Now we have the URL router slash customers, right? Just copy this, go to the browser. Now type it localhost 9191. The URL is slash routers slash customers, right? Enter it. You can see the record here, right? We set it the limit 50. So you can see 50 customer object. Similarly, we can write the REST endpoint, which we already aware about the REST API approach. This is what we can do using the functional endpoint. Just create a router class and then create a corresponding handler class and just mapped it the way we mapped it here, right? This is the URL and this is the handler class. Now let's try for the stream API. Means if you remember in previous tutorial I explained you what is the asynchronous and non-blocking using the stream. Now let's try to design the same using this functional endpoint approach. So what we'll do, we'll just write another endpoint something like get, then pass the URL. I'll copy the same URL, then I'll just add stream. Okay, then we just need to write the handler method. So what we'll do, we'll create another handler class. Okay, so let me create a handler class. Go inside this handler folder or package. Now let me create a Java class called customer stream handler, something like that. Okay, then again annotate this at the red service. So let me minimize this. Yeah, now here again write the method public. The return type will be mono of server response. Fine. Now what will do, the method name get customers. Fine. Then pass the server request. Now here also I just need to inject my DAO class, private customer DAO, inject using auto add. Now first call this DAO dot get customer stream. Okay, it will return flux of customer with delayed 1 second, so that we can print one after another flow of execution. Now just map it to the return type flux of customers, right? Then just write return server response dot okay dot pass the body is customer stream of type customer class, right? Then this is what the handler we write. Now just map this handler to the router. So what I'll do, I'll just inject that private customer stream handler, then I'll name it stream handler, something like that. Then used auto add. Then you can write here stream handler method name get customers. Fine. So let's run this now. Let me stop this, restart it. So we created two separate handler. In next example, I will add couple of method in the existing handler and we can check it. Okay, so application got started. Now go to the browser and let me copy this URL. Localhost 9191. Fine. Now just enter it. Go to the browser. It is printing one after another, right? 7, 8, 9, then 10. And now you got the result here. But this is not what we are expecting in case of reactive programming, right? Though now the flow is synchronous and blocking. So if you observe here, we are expecting a object, list of object in JSON format. And that is what we mentioned in our handler class. But if you will return the stream rather than the object, then publisher will keep on emit the event to the subscriber. Now how I can inform to my publisher to send stream instead of object? So you can do that using the content type. So we just need to add content type, then pass the media type, then event, text event stream. Fine. So this need to add here. Fine. Now data will be sent as a event or data will be sent as a stream, not as a object. Now let's test this application again. Let me stop this and let's rerun it. Yeah, it started. Now go to the browser. Let me copy the same URL again. Localhost 9191 slash router customer stream. You can see that, right? We are getting the stream. And if you observe here, it's keep on getting printed. Now that is what the asynchronous and blocking we understand. And we can able to achieve that using functional endpoint as well by writing the content type. Because basically we are just sending the data as a stream, not as a object. And for each flow, there will be do on next call. That's how we are getting the result. Fine. So far we understand how we can expose the GET API using functional endpoint. Also the URL is straightforward, right? There is no input parameter. Now let's understand how we can use the path variable or request param in this functional endpoint. So again we are going to write one get API or get endpoint in our router. So what I will do, I will just write dot get dot get, then give the URL. Let's say I will give router slash customer slash input. Okay, this is how we define the path variable. Then I just need to pass the handler. Now let's go to this handler. Again, I just want to write the logic in the customer handler. So just go to this class. I just need to filter out the customer object based on the input. That input is nothing the ID. So if you remember, we already write one method DAO.get customer list. This will return 50 customer object. Okay, so from this customer list of customer or flux of customer, I'll just filter the data and I will just return it back. So what I'll do, I'll just write here public, then I'll just copy it. Find customer or something like that. Then pass the server request. Server request. Now from this request, you can get the path variable. If you observe, there is a method called path variable. You just need to pass the name what you mention in this URL. This is what you just need to pass. Okay. Similarly, you can get all the field. If you observe, let me show you what are the field you can get. Request dot. If you observe, you can get the headers. Also, you can get the query parameter. You can get the entire JSON body, path variable attribute. These are the method. Okay. Once we'll do the post API, you can understand few of the method. So let's complete this get, then we'll write one post endpoint. Now this will give me the string value. I just need to typecast it to integer. So what I'll do, I'll just write integer dot value of, just wrap it. Fine. Now I can define int customer ID. So I have flux of customer with me. I just need to filter based on this customer ID. So what I'll do, I'll just call this, then just what I'll do, I'll just filter it, right? Filter c dot get id equal to this customer id, because by default this will return me the 50 customer object, right, as a flux. I just need to filter based on my input. If I will give 2, then it will give me the customer object 2. Okay, now if you observe, this will return me the flux of customer. I just want to return the mono because this is the single, based on the id we will get the single customer object, right? So what I'll do, I'll just write next. Also there is another method, you can write something like take one, then get the single value. This also you can write. So but let me comment this for reference purpose. We'll just call next method. So let me return the variable mono of customer. Now we just need to pass it as a server response, right? So what I'll do, I'll just use return server response dot okay, then dot pass the body as a customer mono of type customer dot class. Fine. Now go to your router config. You just need to remember the method name, that is find customer, right? Go here and just mapped it here. Handler find customer. So we created this get API. Now let's write one post API so that we can test both. Okay. So what I'll do, I'll just type post. Then I just need to pass the URL, something router slash customer slash save, something like that. Okay. Then we'll just write a handler class for it, or handler method. So you can go to this customer handler. Then I'll write one method. Let me copy the syntax. Then I will write here save customer. We don't have any DB, so simply I will get the request and I will print it. So what I'll do, I'll just get the customer object from this request. So what I'll do, I'll just do request dot body to mono. If you observe here, we are sending a single customer object and we just want to save it. So that's why the request will be mono of customer. If you want, you can extract the body to flux as well. So I'll use this of type customer dot class. From request, get the body as a mono of type customer dot class. So just add the local variable. Fine. So what I'll do, I'll simply do the customer mono, just map it something like, I'll name it DTO dot get ID. I'll just simply print it. Okay. Then DTO dot get name. It will return me the mono of string. So I'll name it something like save response or something like that. Fine. Now I just need to build this object and return it. Server response dot OK dot body, as part of request or argument I just need to pass, and it is of type string dot class. Fine. So once we'll do the DB integration, then that time I will show you how we can persist the record as a mono of request or flux of request. So we created this get and post. Now just map this method in our router class. So just add handler save customer. Fine. Now save this. Let's restart our application. So application is up. Now let's go to the browser and let's try to access this. Localhost 9191. Then in input I will pass, for example, 8. There is something wrong. Okay. Yeah, we are getting the object of 8. If I will pass 6, I'm getting the object of customer 6. Okay. Now similar way, let's try to access the post API. Let me open the Postman. Then just write the endpoint. The method type is post. Then HTTP localhost 9191. Then copy the URL. Just pass it here. Then pass the request body as a JSON. So what I will do, I will just copy this, because this is the single customer object. That is what the mono of customer. So go to the Postman, pass it. Now send the request. You can see this, right? This is what we just mapped here. We are just printing it, nothing else. Get ID, then colon get name, and we are getting it here, right? So if I'll do something called 10 customer 10, something like this, or I will just give a valid name, Sam or something like that, we are getting the response here, right? So this is how you can create a router class and handler class, and you can expose n number of functional endpoint. So in my next tutorial, I will show you how we can do the integration test in this reactive programming. We'll write the test case for traditional REST API using the reactive programming. As well, we'll cover the functional endpoint test case. Okay. Previous tutorial, we understand how to write reactive endpoint, as well as we understand how to write functional endpoint, right? In this tutorial, I would like to show you the CRUD operation for a Spring Boot application using Reactive MongoDB driver. Okay, all right. So let's quickly create one Spring Boot application to design Spring Data Reactive MongoDB CRUD operation. Let's go to IntelliJ IDEA, then click on File, click on New Project, click on Next, Then you just need to specify the group ID. I will specify com.JavaTechie. Then artifact ID, I can specify Spring Reactive Mongo, then CRUD Operation, something like that. I'll keep the same name as my project name. Change the JDK version to Java 8. Then I'll just change the package name com.javatechie.reactive. That's it. Click on next. Now let's add the required dependency. I will add reactive web dependency. Then as we are using Mongo driver, reactive Mongo driver, so we need to add reactive Mongo dependency. So if you observe the dependency Spring Data Reactive MongoDB, click on this. Then also if you want you can add embedded Mongo. So let me check the dependency. Yeah, embedded MongoDB database. So this we need for writing test case. Then it's optional for you. If you want you can add Lombok to avoid writing getter setter manually. Now click on next. These are the dependency we need to add. Click on next. Click finish. Now let's go to the pom.xml. So if you observe in pom.xml, we added this data MongoDB reactive, then we had WebFlux, and we added the Lombok dependency. And then if you observe, we added this embedded Mongo for writing test case. So if you observe, the scope here is test, and there is a reactor test as well. Fine. Now what we need to do, we just need to create couple of packages. So let me create couple of packages here. Right click on this, then new, click on package. So I will add DTO. Then I will create another package called entity. Then I will create a package called service. Then you can create a package called repo. Then I will create a package called util. So let me refactor this, shift F6. Fine. Better. Let's create another package called controller. Now let me create a DTO class. I'll create a class called product. Then I'll add couple of field, private, string, ID. Then I'll add private string name. Then we can add quantity. Then I will add private double price. So as you added Lombok, we can directly use @data annotation. And I want all argument constructor. I want no argument constructor. That's it. This is my DTO class, right? So I will rename it to product DTO. Fine. Then let me create an entity class with this field. I'll create an entity class called product. Then I just need to add these attributes. Also I want this Lombok related annotation. You can add that. As this is my entity, so what I can do, I just need to annotate here @document. Also I just need to annotate this as @id. As this is the MongoDB reactive MongoDB we are using, so we need to annotate @document. If you want, you can specify the collection here. Okay, so I will specify the collection name as products. Fine. Now what I will do, I will just create a util package where I will write the logic to convert entity to DTO and DTO to entity. So just create a class. I'll name it app utils. I'll write a method public. Then it will convert product DTO. So I'll name it entity to DTO. Okay. Now I just need to pass the entity here. Entity is my product class. Then I'll just create an object of this product DTO. New product DTO. Then what I need to use here, I'll directly use something called bean utils dot copy properties. So if you observe the copy properties, the argument is object and object, source and destination. So my source will be, I just want to convert this product details to this product DTO, right? I just want to map it. So I can use source as a product and destination as a product DTO. Then I can directly return the product DTO. You can use this bean utils copy properties only if both the class having the same attributes. Okay. Now I will declare it as a static. Similarly, I will write another method who will convert DTO to entity. Okay. So I'll name it product. This will be my product DTO. So method name will be DTO to entity. Then just change this to product. So we just need to change the source and destination. This should be product DTO. Fine. Now the source is product DTO and destination is product. Return this product. Fine. Now what we need to do, we created our app utils, we created DTO and entity. Now we just need to create our repository class. So just create an interface, name it product repository. Then we just need to extend it from Reactive Mongo repository. Okay. Then give the model as your product. Then data type of your primary key is string. Then just annotate this @repository. Fine. Now let's create the service layer. So we'll write all the CRUD operation in our service in a reactive manner. So just create a service class. I'll create a class called product service. Then annotate this @service. We need to inject our reactive Mongo. So private product repository inject using auto add. Then we just need to write all the method here. Okay. So first let's write a method to get all the products from DB. So I'll write a method public. So it will return us the list of product object, right? In reactive programming, we need to use project reactor data type, that is flux. Flux of product, but we just want to return the product DTO because from our service I don't want to directly return the entity to my controller. I just want to return the DTO class. Okay. Get products. Now we can simply return repository dot find all. If you observe, it return flux of product, right? But we just need to return it to flux dot product DTO. So we can do this typecast dot map. Now I can use app util. I can directly use the method reference entity to DTO. Okay. Now it will return me the flux of product DTO. First of all, this repository dot find all will return me the list of product, which is the entity. Then I just convert to entity to DTO. Okay. Now similarly, I'll write one method who will return me the single product object based on the ID. So I can write mono of product get product. Then I can pass the string ID here. Then I can simply write return repository dot find by id. I'll pass the id. Okay, so here also I just want to return the DTO class. This is what the actual coding standard, right? We no need to directly play with our model or entity class. We always need to get a request and return the response with this DTO class. So now what I need to do, I simply copy this. Fine. Now I'll write one method who will return me the product based on the price range. Okay. So I'll write a method public flux of product DTO get product in range, something like that. So I'll make it capital. Yeah. Now give the mean range and max range. Double mean, double max. Then simply write a method return repository dot find by price between. Then we just need to pass this mean and max. Okay. So there is a predefined class in Spring Framework that I can directly use range. Then I can directly use from and to, that is my mean and max. Now we just need to create this method in our repository. Fine. So I will name it price range, something like that. Now we created all the get API. We just need to write a post, put and delete. So I'll write a post API public who will return me the mono of product DTO save product. Okay, and the request will be mono of product DTO so in our DB we can save the entity class, and now we have DTO in our request, right? So we just need to convert this mono to entity, then we can persist it. So what I can do, I can directly use product DTO mono dot map. I will convert it to entity, DTO to entity. Then I can directly use dot map repository dot insert. Okay. Then again, once it will insert in DB, if you observe the method return type is type of S, which will be product, right? But we are expecting product DTO. So again, I will just convert it to map app utils entity to DTO, right? So here we are getting compilation error because it have mono of mono. So we need to use the flat map here. Fine. So this is how, if you don't understand Java, how to use map and flat map, you will get confused while writing reactive programming code. So you must need to watch my Java playlist to understand how when to use map and flat map. One to many, you may need to use flat map. If it is a single mapping, then you can go with a map. Okay. So now I can directly return it. Then we just need to write a update operation, which is put mapping, right? Public, I will again return mono of product DTO update product. Now give this, and also you need to pass the ID. So in case of update, first we need to get the existing object from DB, then we just need to map this DTO class, isn't it? This is what our traditional approach. So what we need to do, first I will get the repository dot find by ID. I will pass the ID. Now I have record in my DB. So then what I just need to do, I just need to map it. Okay. So what I will do, I will just
get the product, but we are not going to persist this object which we get from DB. We just want to map this product DTO mono, right? So I'll use this product DTO mono. Then again I'll just convert this to entity, app utils DTO to entity. Okay. Then I will just use do on next, and here I just need to set the ID because this product DTO is my request. I just want to update this value with the existing ID. So in do on next I can simply write e dot set. Okay, so in my product class maybe I didn't annotate getter and setter. It is there. Okay. Okay, so this we need to change e dot set ID, and I just need to pass the ID which I was giving. Okay, and this we need to convert to the flat map because again it have mono of mono. Fine. Then simply call the dot flat map repository save. Once it's saved, again convert this entity to DTO and return it. Dot map app utils entity to DTO. Fine. Simply just return it. Okay. So again I am explaining if it confused. First I was getting record from DB. Then I used flat map. I got the request object and I convert that request object to entity. As I was just updating the field, so I just keep the ID as it is. Okay, because this is the update operation. Once I map that value, I just save it. Then I return as a DTO. Fine. Now I just need to write one delete API. Public mono of void. Fine. Now I'll write something delete product. Give the string ID. Simply we can return repository dot delete by ID. So if you observe, the return type is mono of void. Just use the same ID. Fine. So if you observe, we added get API, 3 get API, post, put and delete. So there is a spelling mistake. Yeah. Now we can write our controller class. Okay. So let me write a class, Java class, let's say product controller. I just need to annotate at the rate rest controller. Then I just need to add a request mapping which will be root URL. I will name it products. Okay. Then I will write a endpoint to add a product who will return me the flux of product DTO. So I'll write, so first I'll write a get API. Okay, products, something like that. Then I just need to inject my service class here, private product service, service, use auto add. Fine. Now I just need to return service dot get products. Then I just need to annotate at the rate get mapping. Then write another method to return mono product by ID. So I'll copy this, I'll add it here, get product. So I'll name the first method as well get products. Okay, it will return mono of product DTO get product. Then I just need to pass the ID string ID. So just annotate at the rate path variable. Then I can directly pass this ID here. Also in URL I can append this path variable. Then another parameter which will be in range, right? So just add it, get product between range, something like that. Then pass here double min range, double max range, and I just want to use here request param. Okay, so let's add all the flavor for our input. I'll use min. I'll copy this, then I'll add here. I'll name it max. Also, we'll change the URL here, product range, something like that. So just pass here, get product in range, pass the min and max. Okay, so why this is crying? Yeah, so this need to be flux of product DTO. Now we just need to write for post mapping. So let's write public. It will return mono of product DTO save product, something like that. So I just need to pass mono of product DTO mono. Now I just need to call return repository, not this, sorry, service dot save product. Then add this product DTO mono. This I need to annotate at the rate request body. Okay, because this is my post request, and we just need to annotate at the rate post mapping. Similarly, let me write a method for update. Just change this annotation to put mapping, and then this is my request body. I just need to add string id. Just need to annotate at the rate path variable. Okay, so I'll give the URL slash update slash id. Then I just need to change this method call service dot update product, pass the product DTO mono as well as id. Now let's write the last method, which is delete mapping. So public, it will return mono of void delete product, give the id string id. Then I can simply call return service dot delete, pass the id. That's it. I just need to annotate at the rate path variable. Then here I can annotate at the rate delete mapping, and you can give the URL delete slash id. Fine. So we added all the endpoint get, post, put, and delete. Now what we need to do? We just need to add Mongo driver related properties in our application.yml file. So go to the project. Then let me create one application.yml file. Application.yml. Here I will write Spring Data MongoDB. Then I just need to pass the database name. I'll give something like products db or something like that. Okay. Now I will give the host is localhost, and port I will give 27017. This is the default port. Okay. So if you don't have MongoDB installed in your machine, you can use the Docker Compose. You can up the Mongo, something called Mongo Express. If you want, I can share that in my next tutorial. In this current session, I have MongoDB installed in my machine, so I can directly show you this. Okay. Fine. Now also I just want to change the port of my application. Server port equal to 9292. Fine. Now let's go to your main class. Just start your application. So if you observe, net is started on port 9292 and it connected to MongoDB, but we didn't started our Mongo, right? So go to the application, then go to the program file. I have installed MongoDB here. Just go to the server, go to this directory, go inside bin, then type a command and run mongod. Okay. Once this will up, you can go to your search bar and type MongoDB Compass Community. So if you observe here, waiting for connection on port 27017. So it's opening the MongoDB Compass. Just click on this connect. This is what my MongoDB Compass community. Okay. If you observe, it connect to 27017. Now go to the Postman and try accessing our endpoint. Go to the controller. Let's verify the URL. Yeah. /products. Let's copy this. Go to the Postman and change the method to post. Type http localhost then 9292/products. Okay, this is my post request. So just add the JSON. So the first field will be name, right? ID will be auto generated. So I'll give the name as mobile. Then second attribute is quantity. So I'll give the quantity 1. Then I'll give the price. I'll give specify the price something called 10,000. Now click on send. You can see the ID is auto generated, which is type string and record inserted. Now let me add other attribute TV. Let's say quantity 2. It will be cost 50,000. Then I'll add some other product. Let's say a book. 2 book of price 800. Some random product I am adding. Okay. Then shoe. Let's say 15,000. Then something called laptop. 1 of 30,000, something like that. Okay, so we added 5 product object. Now what I can do, I will just simply do the get call to see the list of product or flux of products. You can see these are the product object we added, right? So I just want to search a product based on product ID. So I can simply add this and I will change this to get. Click on send. We can see this, right? Now what else? We have the endpoint. Go to the IntelliJ. So we check this get products. We check based on ID. Now we can check based on the product range. So let's give this URL /product range. Give the mean, which will be request param. Mean, let's say I just want to verify from 5,000 to 30,000 what all products available. Okay, 5,000 and then max equal to 30,000. Send the request. You can see there is 3 product who comes between 5,000 to 30,000. This is what the filter logic, right? Now I just want to update one product object. So let's say this product object I just want to update. So let's change this to put, and what is the endpoint? Let me verify update, right? Go to the Postman slash update, give the ID. Let me copy this, go to this body, paste it here. Just remove the ID because we don't want to pass the ID. This already we are adding as part of header or request URL. So name mobile quantity 1. I just want to change the price to 12,000. Okay. Now click send. Now just do the get call with this ID to check whether the field is updated or not. Do the get call. We can see here the price got changed to 12,000, right? Now we have only one delete. So again I just want to delete the same. Just change the URL to delete. Go to the IntelliJ ID, check the URL slash delete. Now go here and change this to product slash delete URL. So record is deleted because the return type is mono void. We can't see any output here. Now if you do the get call, you can see the record only 4 record. We added 5 record which is mobile, just we deleted, right? Now if you go and check in your Mongo, just let me refresh this. You can find here, right, products DB, and there is a 4 product object. Here also you can see only 4 object, and that's what there in our DB. Now click on this, you can see all 4 product. Just click on table view, you can see, right? So this I shown you because I have installed this MongoDB in my local machine. Do let me know in comment section if you want using the Docker Compose MongoDB. We can expose the MongoDB through the Docker and we can verify the same. Okay. Also in my upcoming tutorial, I will write the integration test case for all these endpoints, all the CRUD operation endpoint test case, integration test case. We are going to write using web client. Previous tutorial we created one CRUD application using Spring Data Reactive MongoDB and WebFlux, right? In this tutorial we'll write integration test for that CRUD application using JUnit and Mockito. Okay, so if you can see here, we created couple of REST endpoint in our previous tutorial. So we are just going to write integration test for all the endpoint, almost 5 to 6 endpoint. Okay, now go to the test, go to the Java, go to the class. So here I just need to annotate run with, then I just need to pass spring runner dot class. So we just need to add JUnit in our class path, then just import it. Fine. Then next just annotate @WebFlux test and just give the controller class name. So our controller class name is product controller dot class. So just remove this. Now here we just need to inject our web test client to call the HTTP method, and also we need to inject our service class to mock that layer. Okay, because we are not going to hit our actual database, so that's the reason I just want to mock my service layer. So just inject the web test client, inject using auto add. Then we just need to add private product service, just annotate here @mockbean, so that it will not create the actual object, it will give us the stop. Fine. Now if you'll go to your controller class, so the first endpoint get product, then save product. So again the name is same, it should be update product. We didn't change in our previous session, so this should be update product. So first I'm going to write the integration test for this save product, then we'll write all the get endpoint. Okay. Now go to the test class. Then I'll write a method public void add product test. Okay. So this should be capital. Yeah. So if you'll go to the save product method, the request type is mono of product DTO, right? So just copy this. We just need to create one mono of product DTO. So I will directly create mono dot just. I can create a new product DTO object. So this should be product DTO. Then I can add the ID something 1 or 2. Then name I will give mobile. Then quantity 1 and price I will give 10,000. Okay. Now this is what my object which I just want to persist. So I don't want to hit my actual database. So what I just need to do, I'll just call when I will call service dot save product of this object, this mono. So let me import this. So it should show me the input statement from Mockito. So let's add it manually. Import static, then org dot Mockito, then Mockito class dot when. Fine. When I call this service dot save product of this object, then I just want to return, then return product mono. I just want to persist the same object, and that's what I was returning here. Now in this case the call will not go to the DB. Then simply we can call web test client. The method type is post. Then give the URI which is slash products. Let me verify the endpoint slash products. Okay. Then just give the body which is type mono of product mono, right? This is what the body. Then you just need to pass the class type product DTO dot class. So let me format this. Fine. Then we just need to call the exchange method and then expect status dot is okay, right? So if you observe, the syntax is very clear, right? The HTTP method type is post, and this is what the URI, and then we are giving the request body, and we are doing the exchange call. Then we are expecting the status as is okay, which is nothing 200. Fine. So you just need to annotate at the rate test. There is something going wrong in my ID. org JUnit. Now if you want, you can run this test method. So I will just run this. There is some error, invalid test class error. Okay. So what we just need to do, we just need to import this Jupyter, because if you observe in your pom.xml file, it added the Jupyter one. That is what the JUnit test it added. I can't show you in this WebFlux project, but usually it added the JUnit 5. Okay, fine. So now if I'll run this, I should get the succeed result. Yeah, so you can see here test passed. Now what we need to do, we just write for add product, which is the post mapping. Now let's write for get products. So if you go to the controller, this is what the endpoint, right? Get products will return you flux of product DTO. So let's write the test case for that. I'll write public void get products test. Now it will return me the flux of product DTO, right? So just copy this, add it here, then just add product DTO flux. I'll just create a flux object, flux dot just. So I will copy this product DTO object. We'll add this. Then we'll add another product object. I will give 103. Then I will give TV. Then price I will mention 50,000. Okay. Now I don't want to hit my database layer. So what I will do, I will call when I will call service dot get products method. Then just return me this flux. Okay. Then return product DTO flux. Similarly, we can do this call. Let me copy this. We'll just change the method. Method type is get, and the URL is, if you go to the controller, the URL is slash products only. So let it be. So we are not going to pass any request body, just remove it. So we are expecting the status is okay. Then also we are expecting the return type. So return result of type product DTO dot class get response body. Now just capture these to a local variable. Then using the step verifier, we can assert the fields. Okay, so that we can verify the get is working as expected. This is what we are just expecting to a return. So what I will do, I will just use step verifier dot create, pass this flux of product DTO, then just subscribe it, expect subscription. Okay, then I just expect next. Then I'll add another, because there is a two object, I just want to verify both the two object. Okay, then verify complete. So in expect next, I just want to check this object. That is what I was just returning, right? So I'm just adding it. Fine. So if you observe, I'm just mocking the API call to return this flux, product DTO flux, and I am just asserting these two. That is what I just returning. Now just annotate here at the rate test. So just run this test case. Yeah. So you can see this test is pass, right? Now there is another get API which will return the mono product object based on the ID, right? So let me copy this, go to the test. Now write another test method, public void get product test. Okay, then this will just return one mono of product object. So just let me create this product DTO mono equal to, I can directly copy this, mono dot just. Now again here I just want to bypass my database call. So let me show you the things, because I'm just writing, maybe it is not clear for all. So from controller we are doing the actual call. Now if you'll go to the service, in service we are just doing our database call, right? So when I was writing when API call then return, request will directly bypass from here itself. The request will not go to your repository class. That you can debug and you can verify. So if required, I will debug at end and I can show you. Now just add it here. So this is what the get product test by ID. So what I will do, I will just write a mock when I will do the service dot get product. by id, so I can pass id as any. When I will call this service.get product, then return me this object product.dto mono. Okay, then I can copy the syntax. It will return me the mono of product object, right? Just add it here. Okay, copy this, change the URL slash products. Let's say give the ID 1 not 2, because I am passing here any call. Okay, so you can pass any ID. Anyway, we are not returning the actual data, we are just returning the mock data. Okay, so then I just need to wrap it to local variable. Now I have my response body with me, so I can do this assert. Copy this. So here I will get the one object. So rather than map expect next, what I will do, I will just verify one of the field. So there is a method called expect some matches. Yeah, next matches. So it will return me the product DTO. So I will check product.get name dot equals mobile, because that is what I was returning here, right? Copy this, add it here, then just annotate @test. So let's run this. Yeah, so you can see here test passed. Now let's write the test case for put mapping, which is update product. Just simply write a method public void update product test. Just annotate here @test. So if you observe the update product, let's go to the controller class. So the update product, there is a two argument mono product and id, which is the product id, right? So just create this mono dot just, I'll just copy one of the object. Fine. Now here what I'll do, I'll just mock the API call. When I will call service dot update product of this mono, and I will pass the ID, which is 102. You can pass any, but I am just giving 102. Then simply return me product DTO mono. So this syntax is very clear, guys. There is nothing to confuse. When I call this method, then just return me this object which I was just hard coded. Okay, that's what the Mockito, use of Mockito. Rather than calling your actual method, you can bypass the API call. And usually in real time, we need to write the test case using Mockito. So now what I just need to do, I will just copy this, the post signature, and I can add it. Slash, let me check the URL, product controller, update ID, right? So just pass the update and pass the ID 102. This is what the, just verifying the status quo. Now what we can do, let's run this test. There is some error. 405 method not allowed. Okay, so the method type is put, right? Now let's run it, because this is the update API, and if you will verify in your controller, the HTTP method is put mapping. So let's run this. You can see here the update product test is pass. Now we write for post get put. Now let's write for delete. So if you go to the product controller, there is a delete mapping, and the return type is mono void. This is what one of the interesting thing in Mockito. you need to write the test case for void return type, which is mono void. Now let's write the method public void delete product test. Fine. So if you'll check in controller, the method took the argument string id and it will just delete the product based on the id. So what I will do, I will just create one mono of DTO class. Even this is not required. I can directly bypass the API call. Given service dot delete product of any, then or else I can write will return mono dot empty. So let me import this. Just add the semicolon. So given a API call, just return empty mono. That's what the mono of void, right? Now what I just need to do, I just copy this, just paste it here. Let's change the URL. Delete ID. Just add it. ID just give any ID because anyway we are not doing the API call, means we are not doing the service call. Even this is the delete. We don't need any body. Simply just pass the API call and expect the status quo. I can annotate here at the red test. Simply let's run this. There is some error. Okay, I just need to change the mapping, right? Means HTTP method. We are doing the delete, but I just copy paste from previous code. So the HTTP method type should be delete. Just run it. Yeah, so it got passed. Now let's run all the test case. Okay, so we created 5 test case. Let's run all. Yeah, so you can see all the CRUD test case get succeed. Now to verify really we are doing Mockito, what I'll do, let's take the any API call. Let's go to this add product test. I'll write SOPLN statement in each API call or each layer so that we can verify where exactly it is mocking. Okay, so let's go to this save product. I will write something is out controller method called. Then let's copy this, add it here. Service method call. Now go to this repository, that is the interface. Okay, so you can only see the controller and service method call. So how can I show you in this repo? Let's go to this because this is the interface. There is no implementation, so I cannot write the SOPLN statement. So let's verify in our controller and service. Okay, no, here also I can prove. Okay, let's run this. Let me run this particular test. Now let's check the SOPLN statement. Only controller method call. There is no service call also, because if you observe in add product or any of the method, we are just mocking the service layer. Even we are not mocking the repo, we are directly mocking the service layer. When I will do this service.save product, then return this object directly from my controller itself. That's how we are giving the URL and we are accessing our controller. So I mentioned wrongly initially that we are mocking the repo, but we are mocking the service itself. Okay, because that's what I added the mock bin in my service. It will return as the stub object, and with the stub, when you will do the API call, it will just return the mock data which we created. So there is no service API call or service layer call. So you can see that in our SOPLN statement, right? But the request is going to the controller based on the URL mapped here. Yeah. So this is how you can write the integration test using Mockito and JUnit in case of Spring MVC and in reactive programming. But again, there is a we already added embedded MongoDB. If you want, let me know in comment section. I can write the test case using embedded MongoDB. We just need to, if required, we just need to mock the repo and we can continue. Otherwise, we just need to create a Mongo template in our test case to verify in our embedded MongoDB. Okay, that's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.